By the way, since we're recording, so I am a department manager of structures with Michael Baker International. That's my current work is at, and I'm here also recording this just so we get to entice you when you go through your course that you at least think about Michael Baker as your place of employment. We're always looking for interns. I mentioned my plug, so so back to my background. So I got my degree, civil engineering degree, focused on structures, Mapua University, back in 2002. That's in Philippines, Manila, Philippines. Been in the civil structural engineering profession since 2000. So as I was taking my college course, we have a family construction business, so that's why I really got involved with what is engineering. Of course, back in those times, I was really more interested with machines. I get to drive the company diesel trucks all over the place, so I like it. You know, all the shaking, rattling, the smell of diesel. Fun fact: when I entered my university, I actually entered as a mechanical engineer because of my fascination with machines, with engines. I like to work on tinker and stuff. But because of halfway through, because of my involvement with the business, it just made sense for me to transition over to civil engineering. So civil engineering is the overall engineering profession that you get to if you want to deal with structures. So civil engineering covers transportation, it covers traffic engineering, it covers highways, bridges, buildings, covers everything, right? Depending on, or ports and harbors even, so waterways. Depending on what you want, you can zero in on structural engineering. You get to structures, there's two columns. You have the bridge engineering, bridge structural engineering. You also have the building structural engineering. So where I'm at is the building side of things. Licenses, civil engineer in Philippines since 2003, Arizona professional engineer since 2009, structural engineer since 2015, and because it's a national company that I work for, licenses all over the place, coast to coast. Okay, structures primer. Kind of going over just what the structural engineer does for a building. Show of hands, so I know the group here. Seniors, juniors, sophomores, I think, are in the mass. Freshmen? Nice, okay. All right. As a structural engineer, let's define engineers first. What do they do? Engineers. Any thoughts? Is it more like trained engineers? No. I mean, by definition, they're also engineers, right? But they do different engineers. Yes?
They design also.
That's right. Add into that. So engineers, we get to design, analyze, and put together using mathematical principles. But at the same time, we also consider building code restrictions, cost impact analysis. Anyone can design a structure, right? Anyone can design a building. I'll use 12 by 12 columns everywhere for a one-story building. That's not being a good engineer, right? Being a good engineer is you factor in what's the most efficient way to do this. That's what that engineer does. For citing an example that's for a building, if you're mechanical engineering, for example, for buildings, mechanical engineering, they do all of the HVAC systems, heating, ventilation, cooling, right? So they're not going to come in. Somebody can always come in and say, I want a 15 horsepower motor for a single story building. That's not really efficient, right? to move the air inside the building, that volume of air and air condition it, you probably need, and I'm not a mechanical engineer, so I'm just guessing here, you probably only need 2 horsepower of a motor, maybe a couple locations, not a big air handling unit similar to a hospital. Okay, so structural engineer, specialized knowledge, training and experience, sciences and mathematics, relating to analyzing and designing force-resisting systems for buildings and other structures. So, as a structural engineer, we're responsible for anything that's supporting framing, structures, etc. Samples of building structures. Up you see on the screen is a steel frame structure. So, you drive around town, you get to see this type of building, right? This type of framing. We get to design those. So, as structural engineers. We get to specify from roof, floor, walls, all the foundations for it, lateral systems, floor framing, etc., different types of materials, steel, concrete, and connections. Pay close attention on the serviceability requirements. So, for a building, overall, we need to design it for code, obviously, right? But serviceability, it might be fine. It might work fine. You know, your members are working just, everything is at 70% efficiency. Everything is good. But you also need to consider the building drifts and member deflections. So I'll talk about building drifts, so that it's kind of cool. For a building, you're designing for gravity, you're designing for lateral flows. When the wind forces gets applied on your building, right? Here in Phoenix, we design to 120 mile an hour wind. That's the peak design that we get. For a steel frame building, and say for example, it's an office building, similar to this building. It's by 101 in Hayden. It's a building I designed, big office building, 5 stories, all glass on the exterior. Just an example. We get to design this to make sure that it meets the strength, but the serviceability side is we need to design the building drift not more than H/400, which is for 10 feet times 5 floors, 50 feet times 12/400. Quick math, who can answer that? Because I don't. I need to calc it out. But we need to design to that restriction. So our drift needs to be no more than 2.5 inches at the top. Because otherwise, you get all these nice, fancy looking glass, right? It deflects more than that, you're going to see cracking on all your windows. And guess who they're going to call once they see cracking and issues with their building? It's probably structural engineer gets the call, but it's not the owner. It's probably their law firm who's going to give you a call and say, hey, we have a problem in your building, et cetera, et cetera. So we never want that to happen. Another thing is going back to presentation slide. You have the serviceability requirements, member deflections. So, ever been to a hospital or a mall where you're walking around and you feel bounciness on the floor? You feel vibrations as you're walking. Right? So, we need to make sure, as structural engineers, we need to make sure that we size that member deep enough or robust enough that it doesn't give you that vibration feeling, right? Before my days getting involved with DODs, for 15 years I've been involved with hospitals, right? So Mayo Clinic, Banner, Honor Health. If you go to I-17 and Happy Valley, north of that, you have the Sonoran Hospital there. It's built out of, it was designed for 6 stories. Right now it's built for 3 stories. It's got a nice big foundation, 4-inch thick foundation on it. or base plates, I mean, not foundation system. But my point is, for hospitals, depending on the use, hospital floors, it's very stringent because you don't want people walking on your corridors next to your operating room where the surgeon is tying up your veins for somebody's operation, right? And then they feel that vibration. So we really need to design to the specific requirement, right? Really stringent requirement. Same thing with the malls or theaters. Right? Mr. Linsky mentioned, there's people get motion sickness when they're in an office building and they feel vibrations. You're focused and trying to do your work because you have a deadline at 5 o'clock, but all this corridor, your office is next to a corridor, and then you feel vibration because of people walking. We're responsible for that. Okay. Building codes, just going over stuff that we designed to. You have the IBC, International Building Code. You have the ASCE, which stands for American Society of Civil Engineers. And right now, because my company is used to working with the government side of things, it's Unified Facilities Criteria for structural engineering. But my point is, as engineers, it doesn't matter which discipline you're in, you will have to design for all the different code restrictions. And again, back to cost. I'm just going to go over very briefly gravity loads. You get to design gravity loads, dead loads, floor and roof framing, assembly areas, different use of spaces. For example, a classroom versus an office building versus a upper floor of again, I'm going back to the mall or a hospital floor, right? Hospital floors, it's automatically designed for 100 pounds per square foot. Upper floors of a retail building, okay, it's 60 pounds per square foot. On the screen storage warehouses, you have light and heavy, 125 to 250 pounds per square foot. So all of that sounds really numbery, right? To put that into perspective, car park buildings, right? Car park garage. Those garages are designed for 50 pounds per square foot. And cars go on top of it, supporting all the cars, right? So imagine your hospital floor is designed for 100 pounds per square foot. So what about partition loads? Say, for example, in an office building. Yeah, you see this all the time, right? Partition loads. We get to factor that in too. Is that a dead load or a live load? So dead load is always that's something fixed. Live load is something that can move around. So code defines the partitions as live loads because according to the code, those can actually move around, right? Today it might be a dentist office with a bunch of dentist chairs, partitions. 3 months down the road, somebody might go in there and become a daycare center with far few partitions. So, again, as engineers, we need to find out first what the use of the spaces and design from there. Something that we don't typically do here in Arizona, but because I design from coast to coast, I also get to deal with snow loads. Snow loads, maybe Flagstaff, there's a bunch of snow. Code also says you need to design for flat roof snow load. But you can see there's a triangular portion there, drift, right? Same thing for a canopy. If you're in a snow area, you have a vertical face of the building or a wall, whatever. You have a horizontal projection. Guess what? When snow blows in, not only will it see your uniform snow, because of that action, it'll eventually build up to somewhere, some with a triangular load at the top. That's called the snow drift. So, I don't want to get too nerdy with you guys, so I'm going to skip forward. Loads, you have wind loads, you have seismic loads depending on the location that you're designing a building on. But I want to focus more onto this. So you have a project, a building, right? Somebody owns the building, you have the owner, the client, contractor, design build partner, what have you. On the design side of things, which is us, the consultants, you guys in the future, right? You're going to be the consultants. Depending on the discipline that you get yourself into, it could be architecture, it could be structure, mechanical, electrical, plumbing, fire protections, interiors, other disciplines, right? So, project management, for those of you who are wondering, especially the seniors here, project management is already considered a discipline in itself, because you get to deal with all these designers here, and I'm telling you right now, you have designers who are strong opinion, strong-willed designers, right? You need to interface with the owner side of things. Make sure you communicate all the design intent to what the owner and the client needs, right, and their wants. Architecture is also another discipline. So architects make everything look nice and fancy. Right? Structures, I just talked about structures for the past 10-15 minutes. We make the building stand. We are responsible for making sure the building is stable, it's efficient, and then you get to stamp your name on the documents and sign your life away. In reality of things, that's what it is, all disciplines, right? So take your discipline, take pride in your discipline, in your profession, whatever you choose, right? It could be electrical. Electrical will design all your, a building is not a building without usable facilities inside. Right? Can't charge your phone? Oh, that's the electrical engineers thing, right? They need to make sure everything's powered up with a certain amperage connected to the power grid. It needs to power all the mechanical equipment inside the building. I was talking about mechanical earlier. They design HVAC. They need to size out the proper machines, air handling units, heat pumps, etc., to make sure that they move enough air and have a nice, cushy, air-conditioned space on the interior of your building. Plumbing, obviously, they need to make sure that there's enough services and running water inside your building. Fire protection, life safety. Obviously, for a building, you need fire protection. See all those sprinkler heads. Somebody designed it, make sure that there's enough space in between that the zone of water, once those get activated, provide enough coverage, enough overlap, right? And interiors. So interior designers, let's not forget them, because if it were left to the structural engineers, we'd be fine with just a desk and a table. That's it. There's no fancy fabric, there's no fancy paint colors. It's usable, quit complaining, right? But no, that's not the case. It's a very good profession. I think we went over the role of the structural engineer earlier. I included the slide just to show you guys what, as defined by the code, defined by law, what the roles of a structural engineer is. So, for a building, doesn't mean you get to only have one structural engineer. It could be somebody else might be designing your steel joists or your prefabricated walls. But there can only be one designer of record. So, going back to here, all your other disciplines here, for each project, there's only one designer of record for each discipline. And I guess that's where I'm going to try and wrap it up, making sure that you guys have that goal of becoming a designer of record someday, depending on which engineering discipline that you choose. I, for one, it's structures, but depending on what you like, machines, all the robotic stuff that you do here. Just remember that because of your profession, you will always be part of the team, right? For a successful project, whether it's a building or whatever project that is, maybe you're building a naval ship, for example. All the systems that go into a naval ship, computers, information systems, structural steel, and the welders, all of those disciplines are still part of the team. So just make sure that you're aware you're still part of that group. Anyway, any questions?